Hello everyone, welcome to Mr. 8 online class. In this video, we're going to review for chapter 1 test. We're going to go over each question and I'm going to explain to you each term as detailed as possible. And please don't forget to take note, write it down. If you have any question, please ask me in class. Number 1, Jasmine is analyzing numbers. Part A, select whether the number in each situation is rational or irrational. So in class, we already talked about rational and irrational. Excuse me. Rational numbers is numbers that can be rewritten in fraction form. Here's the few examples for rational numbers. Let's say 2/3 is a fraction, is rational numbers. If you have 0.5, which can be rewritten as written at 1/2 is a fraction form, so it's also a rational numbers. Or we can talk about the whole number, like 3. Whole number can be represented as a fraction, so 3/1. So 3 whole number can also is also a rational numbers. And let's say if I have square root of 4, square root of 4 is 2, and 2 can write in fraction form, which is 2/1. So square root of 4 is also a rational number. So, and what is irrational numbers? Irrational number basically is not rational numbers. Irrational numbers. Okay, I want to add on my rational number a few more examples. If you have a fraction, let's say 0.25, if it's ended, then you can write in the fraction form, which is 25/100. So this is a rational number. Or you can have 0.252525 repeated multiple times. So I put the bar on top. So with this one, we can also represent it in the fraction form by move the decimal point 2 places, 25/100. Then seeing it repeating, you're going to take away 1. So in fraction form, it's 25/99. So rational numbers, either a decimal number, a whole number, a square root, a perfect square number, a decimal number, yes, we did talk about it, and repeating decimal number. So what is irrational numbers? Irrational number is number that cannot write in the fraction form, or they have a decimal number with without any repeating, or they repeat without any pattern. For example, if we talk about square root of 2, give me 1 second. Square root of 2 is 1.414213562, and this keep going forever without any pattern. So square root of 2 is irrational numbers. Irrational number. And square root of 5, for example, square root of 5, that will be 2.236067977, and this keep going forever. Beside that, we have like pi is 3.1415, 3.1415, and a bunch of number come after that, and it's never stopped, and they don't have any repeating number in any pattern. So that's why pi is also irrational number. So we're going to look at the example 1, the first problem. The volume of a cylinder is 17/3 cubic centimeters. So this is a rational number because it's in the fraction form. The second part, the area of the floor covered by a circular rug, it is 3 pi or 25.132741.2 square feet. Seeing the pi in there and the number that they gave you, it didn't stop. It's 3 dot mean that it's keep going forever, so that will be irrational number. The bottle contained 0.12 with the bar on top, which means 0.12. It repeat forever, but it repeat in pattern. So that will be a rational number. If I want to write this in a fraction form, I move the decimal point 2 places. So 12 over 100, because we move it 2 places. And it's repeating, so you take away 1, 12 over 99. Then we can also reduce it by 3. That will give you 4 over 33. And since this can be written in the fraction form, it's a rational number. The last one, each side of a square measures square root of 25 centimeters. We know that square root of 25, which is 5, since it's a whole number, you can write it in a fraction form, 5 over 1. That would be a rational number. Alright, part B. The diagonal of rectangular tile A is 5 square root of 3 inches long, and diagonal of rectangle tile B is 3 square root of 5 inches long. Which tile has longer diagonal, and explain in detail how do you got the answer. So as we know that square root of 3 and square root of 5 is irrational number, and during the test we are not allowed to use a calculator, so we have to use the estimation that we learned in class. First I want to look at 5 square root of 3. Okay, 5 is a whole number, we know what it is, but square root of 3 that we don't know. So we're going to put square root of 3 less than equal to, less than, greater than equal to. There's two perfect square number that's square root of 3 is in the between, is 1 and 4. Since square root of 3 is closer to square root of 4, and square root of 4, the answer is 2, square root of 1, the answer is 1. So the estimate answer for square root of 3 will be 2. Then we will have 5 square root of 3. The estimation of square root of 3 is 2, then we can replace 5 by 2. That will be 10. So the estimate 5 square root of 3 is 10. We're going to do the same for the second tile, 3 square root of 5. 3 square root of 5. Square root of 5 is lying in the between of two perfect square number, which is square root of 9 and square root of 4. Square root of 4 is 2, square root of 9 is 3. So which one is the best represent for square root of 5? Since square root of 5 closer to 4 than 9, then the estimate value of square root of 5 is 2. So we have 3 square root of 5 can be rewritten as 3 times 2, which is 6. Now, so we can see that square root of 5 square root of 3 is the first tile, has the estimation is 10, and second tile has the estimation is 6. So we have 5 square root of 3 is a larger or a longer diagonal. So our answer is 5 square root of 3 for part B. Alright, number 2. We're going to go down to number 2. For number 2, they want you to sort the expression into appropriate bins based on their value compared to 7. Alright, so we have to evaluate each expression and make sure you show your work. The first box I have 7 to the 9 over 7 to the 10. So what we're going to do is, since it divide, we subtract the exponent. 7 raised to 9 minus 10, which is 7 to the negative 1. And we learned about this. If we see the negative exponent, you put 1 under and you flip it. That will give you 1 over 7. And 1 over 7 less than 7. So let's go to the first box. 7 to the 9 over 7 to the 10. It's less than 7. Now the second problem, we have same problem but different numbers. So we're going to subtract the exponent. One more time, when you divide the power with the same base, we subtract the exponent. 7 to the fifth power minus 3, which give me 7 to the second power, which is 49. And 49 greater than 7, so we will put that into the last box. 7 to the third power, and go ahead box it. Alright, the next one, 2 to the 6 times 2 to the negative 3. I'm gonna move it up here, 2 to the 6. Since it's multiply, when we multiply the power with the same base, you're gonna add the exponent. Alright, since we have positive times negative, that will turn into a negative. That will be 2 of 6 minus 3, which is 2 to the third power, and 2 to the third power is 8. So it's also greater than 7, so that go to the last box. 2 to the negative 3. I don't know why it's broken writing. Alright, the next one, you have 7 to the second power times 2 and all raised to 0. So as we know, they are inside a parenthesis, and this parenthesis raised to 0. Whatever raised to 0 equal to 1. So we don't have to solve for that one. So less than 1, that will be this part. 7 to the second power times 2 raised to 0. Alright, next one, negative 5 squared. Negative 5 squared is negative 5 times negative 5. That will be positive 25. Is greater than 7, so it belongs to the last box. And last one, we have 7 to the negative 2 and 7 to the negative 3. Since they both have a negative exponent, we're going to do is flip them both. 7 to the third power going up. 7 to the negative 3 power going up as 7 to the third power. And 7 to the negative 2 will go down as 7 to the positive 2. And our next step is subtract the exponent 3 minus 2, which is 7 to the first power. That's the only problem that equal to 7. 7 to the negative 2 over 7 to the negative 3. Alright, now we go down to number 3. The area of the fallen world's oceans are listed in the table. Order the oceans according to their area from the less to greatest. I have typo on this one, is less from least to greatest, from the least to the greatest. Alright, so by looking at these numbers, we're gonna pay attention on the power first. We're gonna group them by power. So we know that 2.96 times 10 to the 7, 2.65 times 10 to the 7, and 6 times 10 to the 7. Because the power of the exponent is higher than the other one, so all these three numbers is bigger than the other three numbers, the other two numbers. So 5.43 times 10 to the 6, and there's one more, 7.85 times 10 to the 6. Then we're gonna do is we're gonna break down each group. So for 10 to the 7, all 10 to the 7, we're gonna break down based on their first decimal number. So 2.96 greater than 2.65. And actually 6 is the biggest number. So 6 times 10 to the 7 greater than 2.96 times 10 to the 7 greater than 2.65 times 10 to the 7. Now the next one is 10 to the 6th power. So that bigger number is 7.85 times 10 to the 6th and greater than 5.43 times 10 to the 6th. On the table, or in the table, they already has to set up from least to greatest. So we're going to re-put all the numbers into the box. So 5.43 times 10 to the 6. Make sure you put them in the correct order. And next one going to be 7.85 times 10 to the 6. Next one is 2.65 times 10 to the 7. 2.96 times 10 to the 7. And last one is 6 times 10 to the 7. Then we chase the name. 5.43 is Arctic Ocean. 7.85 is Southern Ocean. 2.65 is Indian. 2.96 Atlantic. And last one is Pacific. Alright, so that's it for number 3. Number 4, Josh is finding area of a square with the side length is 7 x y to the 5th power. His work is shown in the box. Part A, circle the step that show an error. So my suggestion for you for this kind of problem, you want to do is solve the problem by yourself first. What I'm going to do is rewrite the problem and solve it by myself and then compare to see what was wrong. Because for me, I have a hard time to find people's mistake. But if I solve the problem by myself, I can compare back and forth and I say, oh, that was the mistake. So we're going to solve this problem. 7 doesn't have any power, you're going to put 1. And x doesn't have any power, you put 1. This is power to the power problem. Because 2 parentheses raised to 2nd power, you're going to do is multiply these numbers together. So that will give me 7 to the 2nd power, x to the 2nd power, and y to the 10th power. After that, we're going to solve for 7 to the 2nd power, which is 49, x squared, y to the 10. Now we're going to look back. So far I see that I have y to the 10, this is y to the 7. That is wrong. And the second thing is my 7 squared is 49, not 14. So that is 2 mistakes from Josh. Let's see, second line, it's okay. It's y to the 5th power raised to the 2nd power. I see what he's doing. He's going to get y10 eventually. So second step is also good. So first, second, and third, just the last step is the problem. Alright, part B, find and correct answer for the square. See, they ask you to solve it eventually. So since we already did this, we just need to do is all the step right here bring down to part B. Part C, describe Josh's errors in detail and how he should correct his work. So basically, you just need to compare back and forth between his work and your work. So explanation, I would say that Josh miscalculation as step 3. Alright, 7 squared is 49 and not 14. And sorry, I should have a period right there. And y to the 5th power raised to the 2nd power is y to the 10th power. And pretty much it. Okay, that's multiple answer for part C. So it's up to you. How do you see the problem and how do you explain it? So that is the open question for you to write down your